Okay, so let's move into the next section. We're going to be dealing with matrix algebra. So here's the thing. When we learn a new set of numbers, we need to learn the algebra on those new set of numbers. Think about it. When you first learned those counting numbers, when you first learned about those negative numbers, when you first learned about those fractions and then those decimals, and even polynomials, you had to do algebra. You had to learn how to do algebra on them. Well, you're like, well, what do you mean by algebra? We learned how to add them, subtract them, multiply them, and then divide them. That's what we learned. That's what it means by learning the algebra on the new sets of numbers. Well, matrices can be considered a set of numbers. They're contained in these rectangular formats, but they can be considered a set of numbers. And we need to learn how to add them, subtract them, multiply, and then divide. Are you with me? Okay, so first let's talk addition and subtraction. So you know, addition and subtraction are quite easy. But addition and subtraction are two of the pickiest operations that we work with. You can only add or subtract things that are the same, right? If I wanted to do 1/2 plus 2/3, you can't add or subtract them until those denominators are the same. Agreed? If you wanted to add an x and a y, you can't do it, because x and y are two totally different letters of the alphabet, so to speak, right? Okay, well, it's the same with addition and subtraction of matrices. I have to make certain that the order of the matrices are exactly the same. Remember what I mean by order? Right, I mean the size of the matrix, correct? And remember, when you talk about the size of the matrix, you do the number of rows by the number of columns. Good? All right. So, by the way, as I'm speaking, please make certain you write these matrices down or take a picture of them or something, because we're going to be using these in the next few problems. So let's just go over the order of each matrix. So matrix A, what order is matrix A? Yes, it's a 2 by 2. What about matrix D? It's also a 2 by 2. How about matrix B? Yeah, don't get fooled. It's 1 row, 3 columns. So it's a 1 by 3. How about matrix C? Good. 3 rows, 2 columns. So it's a 3 by 2. Matrix C? Yeah, that's another one you got to be careful of. It's 1, 2, 3 rows, 1 column. So this is a 3 by 1. How about F? Good. That's a 2 by 3. And finally G. Good. 3 rows, 2 columns. That's a 3 by 2. So here is the order of these 7 matrices. And when you're going to add and subtract matrices, the orders, their sizes, need to be exactly the same. So which matrices could you add or subtract together? Good. You can add or subtract A and D together. Good. What else? Good. E and G you can add or subtract. Good. Anything else? Yeah, no, because the orders aren't the same. So there's nothing else, there's no other matrix listed, at least on here, that you could add or subtract together, right? All right, so as I mentioned, I hope you copied all of these down or took a photo of them, because we're going to use them in the next few problems. Okay, so let's look at some examples. Remember, you told me we could add matrices A and D together. So problem number 1 is asking you to add them. So it's very important to keep the order in which they asked you to add. A plus D, I wrote the A matrix first plus the D matrix. Now, here's why it's very important for the order to be exactly the same in order to add these or subtract them. You are actually superimposing one matrix on top of the other. There are 4 numbers in matrix A. There are also 4 numbers in matrix D. So, if I want to add these matrices, I need to add the exact same locations together in order to accomplish this. For instance, 4 is in the first row, first column, which means the only number I can add to this 4 would be the 7. Why? because it's also in the first row, first column position. Understand? Okay? If I want to add 2 to one of these numbers, 2 is in the second row, first column position, which means I have to find the number in matrix D that's also in the second row, first column position, and that would be 5. Understand? Good. Keep it simple. This is gratefully, it's very easy to add and subtract these matrices. So, 4 is in the first row, first column position. So, the only number I can add to it is, good, the 7, because it's also in the first row, first column position. -3. That's in the first row, second column position, which means the only number you can add to it, good, is the 2, because it's also in the first row, second column position. Does that make sense? Getting the hang of it? Yeah, remember, it's like taking matrix D and superimposing it on matrix A and going, well, which numbers are going to match up? So 2 is going to get added to 5, and the 1 will be added to the -3. And when you simplify this, we get in the first row 11 and -1. Second row is 7 and a -2. And the resulting matrix also has the order of 2 by 2 because I added 2 matrices whose order was 2 by 2. Good? Okay, number 2. Yeah, no surprise, right? You're like, okay, I think I got the hang of it. Great, well then pause the video. Okay, you paused it? You did your work? Good. So let's see if you and I are agreeing. I'm going to add the 2 and the 7, the 0 and the -2, the 4 and the 1, the -1 and the 3, the 3 and the 4, and the 5 and the 2. Remember, take matrix G, superimpose it on matrix E, and you can see the numbers that are matching up with each other, right? Okay, so when I simplify this, if you haven't simplified it yet, pause. Okay, here are the results on the first row, the results for the second row, and the results for the third row. And it also has the order of a 3 by 2, just like the original 2 matrices. Cool? Okay, hang in there. Got a couple more problems. Okay, so problem number 3. Problem number 3 is actually asking me to take the number 4 and multiply by matrix C. So here's the number 4, and I'm supposed to multiply it to matrix C. Now here's the deal. Don't think too deep about this. In order to do this multiplication, this is basically a distribution problem. I am going to take that 4 and I'm going to distribute it to every number inside matrix C, which is probably what some of you are thinking. So that means I am going to have in matrix C -3 times the 4, and then 1 times the 4, and 5 times the 4, which will give me -12, 4, and 20. Does that make sense? Good. Yeah, don't think too deep about it. Look at number 6. Now notice, it's asking me to do 2a minus 3d. Agreed? Okay, so first off, let me ask you something. When you are subtracting, isn't it easier if we change our subtraction problem to an addition problem? Because don't our brains work in addition? So here's my suggestion to you. My suggestion to you is this. On matrix A, you are definitely distributing a 2. On matrix D, I suggest not multiplying a 3 in, but I'm going to change this to addition and make that 3 negative and say, hey, distribute a -3 into matrix D. Because then all my brain is left doing is literally adding the 2 matrices together. Does that make sense? Okay, So when I do times matrix A, when I do 2 times matrix A, tell me what you get in the first row. Good. 8 and negative 6. What do you get in the second row? 4 and 2. Excellent. Now remember, it says it's going to be an addition problem because we've decided to distribute a negative 3 into this matrix D. Okay, so what's the first row going to look like? Good, negative 21 and negative 6. Excellent. What's your second row look like? Negative 15 and positive 9. Great, good job you guys. Okay, and now it becomes very easy to add these two matrices, doesn't it? All right, so let's add them together. What do you get in the first row? Negative 13 and negative 12. What do you get in that second row? Negative 11 and positive 11. Wonderful. Good, makes sense? Awesome. Okay, so adding and subtracting matrices, not really a big deal, is it? Even distributing a single number inside, really not a big deal, right? Okay, so keep this simple. And I'll catch you on the flip.